Hello, good morning or good evening. We are speaking today about the health and safety issues of batteries. So I'm Héloïse Genard and I'm working together with Elise.
Hello, I'm Elise Nanini-Mori. I'm the electrochemical expert for the ENG Batteries Lab located at Laborelec in Belgium.
We worked on health and safety issues for batteries together with Global Care and developed some guidelines for the group. We will explain you today the main issues. So first of all, some explanation about batteries, the potential hazards that we can find, and some good practices to avoid all the risks. Let's start, Elise, with some explanation about the batteries. Can you explain us what is really a battery? How does it work?
Yes, indeed. So battery is part of the solutions used to store the electricity. So we have the pumped hydro storage, which represents the most value of storage of electricity worldwide, but batteries is really on the right side. We see different batteries are present, and it represents a part of the storage. And it's also a growing activity for the group, for ENG, but we have some classical batteries such as lead acid batteries, which is present in all our power plants as backup, as power backup, also together with some generators. And it's an electrochemical product. Electrochemical, it means that through chemical reactions, we produce electricity or we store electricity. So what we see there, it's a lead acid battery, the most mature technology and the most developed worldwide and present in our power plants, for example, is divided into different parts. We have what we call electrodes. It's where we have the electrochemical reactions to produce or store electricity. We have also what we call an electrolyte solutions. It's where the ions are exchanged, and it's where, in fact, the energy pass through. For the specific case of lead acid, this is an acid. It's a sulfuric acid, but for other technologies, we have other electrolytes. We have the reaction, but what is important also for lead acid is that a normal reaction is to produce oxygen and also hydrogen. And hydrogen is necessary for the good work of this battery, but could be also an issue in some cases.
But there are also other types of batteries, because, for example, in our mobile phone, in our computer, and so on, can we find which type of batteries will then we find?
So what we have in our mobile phone or in e-cigarettes, for example, in laptop, it's mostly now lithium-ion batteries. So we heard about lithium-ion batteries. It's just because it's light and it's really easy to store electricity. But we have also other various types of batteries in tools like nickel-based. So what we call nickel metal hydride in green there, or nickel cadmium in orange there. And of course, we have a lot of lead acids, as I said, for energy storage, for backup, but also for forklifts and in our thermal cars also. So the choice of batteries is mainly based on different considerations, mainly the energy we can store, the power it can deliver, the cost, the durability, and also the operating range. But safety is also a part of choice normally, and we are going to develop it more. And for stationary applications, we have, of course, the lead acid, which is mature, where the cost is low compared to other technologies. But we can have an overheat. We can have also the hydrogen production, which is a danger. We have also the lithium ion for stationary applications, because it's light, because it's easy to have a lot of energy in a small space. But still we have a safety issues due to the thermal runaway. We will develop it at the end of this year during a MOOC together with Global Care. Nickel metal hydride is also used, and for stationary we have also some new chemistries like the redox flow batteries, where we have an exchange of fluids and chemicals to store the energy.
what are then all the potential hazards? Because we know all, we heard about the mobile phones that exploded. We know also there is of course an electrical risk because it's not possible to really stop it even if it's not connected to the grid. But then are there other issues? Is it really for all batteries? What can we do?
Yeah, so whatever the battery, in fact, is really difficult just to disconnect it. Even if disconnected, the battery is always alive. There is always electricity inside. So what are the possible hazards? Mainly human error is an hazard. In case you mix batteries, in case you misconnect the battery, you have an hazard. There is, of course, an electrical hazard due to the fact that you have electricity and it's always alive. You have a fire or explosion. It happened that battery explode, as you mentioned. We already saw that for mobile phones, for cars, but also for batteries with generators. As I mentioned, we have a chemical hazard because of the electrolyte. For lead acid, we have a sulfuric acid. For lithium ions, we have other electrolytes. If we have a leakage, we are in direct contact with chemicals. We have also a mechanical hazard just because we can change and perform the manutention of batteries, and it's a heavy project and it's easy just to be quenched by batteries. The thermal hazard, you already noticed it with your mobile phone when you charge it, or you charge it fast, or if you use it a lot, you can hit the surface. So this is all the hazards we have.
For the main accidents, we know that human error can be a big issue. Almost 60% of accidents are due to a human error if we look to accidents in general. But then what precisely can be dangerous in a battery? What can we do wrong?
What we can do wrong with batteries, so what we can after that call a human error, is a misconnection, is also a mix of batteries. If you use different kinds of batteries or different age of batteries, a new one and an old one, you are going really to exhaust the battery and to be in danger, in close danger. You can also perforate the battery, it's also a human error. But here we are going to see really what could be. For example, an improper packaging or an anomaly during the maintenance work. You have, for example, an unexpected connections between the two poles, and you provoke an external short circuit. So we also have the electrical hazard, which is not human error, but purely electrical hazards due to the voltage we have with batteries and due to the currents we have also. And we already saw within ENG or outside ENG that we have these hazards and leading to some incidents and accidents. So for an example, work was to recable batteries after their replacements. And the accident was due to an error during the electrical connections where a shortcut was experienced. And this shortcut just caused an important arcing, and as consequences, so we have the electrical arc, but also the electrician was injured and his hands the hands were burned. So to show you how the work was done, so here you have all the batteries, and it was the recabling of batteries. So you recable in that way, so connecting plus and minus with another battery. And the error was to reconnect wrongly the batteries, creating a shortcut. So the consequence was an electrical arc, so which is a high temperature and a high electricity content, with the people injured in the events. We can also have fire and explosion hazards with batteries, and I'll let you, Eloise, because it's your expertise, explain it.
So about a fire, what we need, we all know this fire triangle. So we need to have fuel, we need to have an ignition source, and we need to have an oxygen present. The problem with batteries is that we have already a fuel, because we produce hydrogen, we have some parts that can burn. we have, of course, an ignition source because of the presence of electricity and of energy, and oxygen is present in the air. Compared to an explosion, we need some additional aspects. We need to have dust or gas in suspension, and we need to be also inside the explosibility domain, which means that we need to have the good mix between gas and between oxygen. And also, the last aspect is confinement. Why is it important to have confinement? If you have just a gas leak in open air and you ignite it, you will not get this pressure wave that you see in the explosion that will really destroy everything. You will have some high temperature, such like a wave of high temperature, and you can get burnt, of course, and it can be very dangerous for the people just next to it, but it won't destroy all equipment. On the contrary, if you have a confinement, so for example, you put just gas in a bottle or something and you ignite it, then the volume will try to increase because you get more energy, you get more heat, and it's not possible because the volume is confined. Then it will get up in pressure and more pressure, and at a certain moment it will completely explode and destroy everything close to it. That's why it is so dangerous. About the explosibility domain, we have two limits. We have on the right side the lower explosion limit, which means below that we don't have enough fuel, so it won't explode. And we have the upper explosion limit. Above that, you don't have enough oxygen and it's not possible to ignite. So you need to stay in the good range in between. So this means enough fuel, but also enough oxygen. And can we get that perfect mix inside the battery? That's the big questions. Can we really get, we saw, Elise explained us that we can get hydrogen produced by lead acid batteries. This hydrogen is flammable. If we get inside the correct mix between hydrogen and oxygen, we get an explosion. Is this possible, Elise?
Yes, indeed. So as mentioned just before, we produce hydrogen with lead acid batteries. And we have also a mix with hydrogen and oxygen in the normal work, in fact, of lead acid. But it's in a confined space. It's in the space of the battery. And 1 ampere hour, so it's, for example, the reserve of energy is expressed as ampere hours, produced almost half a liter of hydrogen. So yes, indeed, we have this, gas produced. And even if for lead acid, we have what we call open lead acid and closed lead acid, even in the closed one or the sealed one, we produce hydrogen because it's part of the reaction. So the name of lead acid, we have just to remind that hydrogen is always produced, and based on that, we have to take care of these batteries and of the room and the ventilation and of the explosion limits we can have.
So if I'm correct, Elise, inside the battery, we produce hydrogen, so we have our fuel. It's getting in suspension. We can be in the explosibility domain because it produces oxygen. So the only thing that is missing is the ignition source inside the battery. So the main risk can be if this hydrogen is vented and it goes to the open air, and if we have there some ignition source, it can be dangerous.
Yes, indeed. And to ignite it, in fact, the hydrogen is very easy. So for example, you need only 17 microjoule to ignite it. And as an example, 17 microjoule is comparable to 2 snowflakes in contact. So it's really nothing. Yeah? So
of course, it's nothing. So that's why it's very important to prevent venting of hydrogen and to avoid any ignition source close to a battery.
Yes, and we have also lithium-ion batteries. So we are going to develop also this today a little bit. We can also produce gases. We can have an internal cell explosion. We are in a closed area inside a cell, inside a battery. We can produce a lot of oxygen during the decomposition of some electrodes. So we have part of the explosion conditions. We have also flammable gases. We are in a closed area. And it's really similar to have this in lithium ion because of the variety of gases we have inside. And it's also the reason why some manufacturers just put a vent on top of cells, but we have to take care when the vent is acting not to have these gases accumulated, for example, in a rack or within a room where people are passing through.
The ventilation inside the room where we store batteries is thus very important.
Yes, indeed. Just to extract all the gases we produce, toxic or explosive. We will see some toxic gases also, and in order to ventilate the room and not to accumulate these explosive gases in the room. So we have explosion limits of various gases. Hydrogen produced in both batteries, but mainly in lead acid batteries, and other explosive and toxic gases we produce in batteries in general. And no, I'm going to show you that it's not theoretical that we can reach the explosion limit.
You have examples of explosions that happened?
Yes, we noticed various explosions inside NG and outside NG of batteries. So for example, here it's an explosion of lead acid batteries. So this battery was fully discharged for some times. It was for a diazel group, and 2 batteries over 6 exploded during this event. What happened in fact is that we had various batteries, not at the same level of age, and also not at the same level of charge. One was really fully discharged, and we had old batteries close to the replacement period, and the production of gas was really high, and just starting it put the battery under severe and extreme conditions for the gas, and was followed by an explosion. So when we were on site also for this event, we analyzed in fact this event, and we perform also some recommendations for operation, and it can be applied to everyone. First, there is a legislation, there is norms on lead acid. So first we have to follow it to mitigate the risk related to the gas produced, related to the chemicals, and also we have to take care about what are the distances, the age of batteries, and what has to be applied.
In the standard, we can find back the ventilation that is required in the room,
yes,
and we can find back the distances that must be respected between batteries and the rest.
Yes, indeed. And also what we expose it, we did not to use lead acid battery once fully discharged. It's part of the chemical process. It's inhomogeneous somewhere. We have to re-homogenize, and it's really after that you can crack the water you have inside within the electrolyte before you have so you have acid dissolved in water. You can crack it and perform also production of hydrogen and explode it.
So in this case, the fully discharged batteries must be disposed of.
Mm-hmm. Yes. And in this specific case, so the diesel motors was started several times without a long waiting period between 2 starts. So it's like you ask a lot and you stress a lot really quickly, an old battery and fully discharged. So it was really painful for this. And also there is procedures normally to be followed for the inspection. So it could be yearly, it could be before, depending on the use. But this, after 2 years of installation, we have also to take care of this battery and be sure that the gas does not accumulate in batteries before we move it. Once you remove it for the maintenance, you always have some gases accumulated within the battery.
And if one of my batteries is too old, I see that it's damaged, I need to replace it. Do I need to replace only these batteries or also more batteries?
No, if you replace only this one and you have a new one, so you have a mix between old and new battery, and at that moment you will exhaust more and more both batteries and be in danger just to the mix of batteries. So you really have to take care about that.
So I will need to replace all the batteries if I need to replace one.
Yes, not only the battery which exploded, but really all the batteries are in the same rack. And really do not mix batteries. And what we also perform as recommendation after this accident was to ventilate the room, because you can have hydrogen as mentioned, but for some kind of lead acid batteries, depending on how the battery was manufactured, you can have toxic gases also present. And you have also to protect the operator against the acid spilling and against the elevated temperature right after the explosion. So it's acidic and hot once it's an explosion.
So better to wear gloves.
To wear gloves, to have also your glasses, and to have also a shower close to you in case you have you are touched by the acid. So there is a lot of recommendations, but at the end I will put all the links where you can find everything.
And what about the other risks then? So we spoke about the chemical risk.
Yes. So for the chemical risks, here I took the example of lead acid, but it's the chemical hazard is present for all batteries. But you can have explosive gases, but you can have also toxic gas emissions. For lithium ion, you can produce HF, so fluoride acid is emitted. You can have other toxic gases due to the decomposition of the solvent, of the electrolyte, you know, the liquid we have between the electrode. So here is a non-exhaustive list of what could be emitted. And we can have, as mentioned before, the leakage of electrolyte. For example, you you have a perforation of the cell of the battery, or the battery fall down, you can open mechanically and damage mechanically the battery, and then you have a leakage of electrolyte. And electrolyte can be acidic, like for lead acid, like for nickel metal hydride. It can be basic also, like for lithium ion. So you have really to take care about all the chemicals you have. And everything, in fact, all the risks are already mentioned. You know, when you buy, when you purchase a battery.
Where can I find it?
So you can find it directly on the product. So here is an example of what we see or sticked on the product or in the manual user guide, and you will see there that we have and we can see all the different hazards. So first hazard we can read there is batteries give off explosive gases. So it's an example of sticker of lead acid, but it's the same for other batteries. So as a recommendation already written, it's avoid electrostatic charge. Really don't initiate it. We have also the chemical hazards because it's filled with sulfuric acid in the case of lead acid. So always wear the protective clothing and glasses. You have also the electrical hazard. You have exposed metal part of the battery, so and the battery is always electrically live, even if you disconnect it. And also you have rules and recommendations, and you have to follow some standards also. And there is a lot of protective measures already exposed in some standards. So this is the safety precautions written, but we have also the safety precautions reported. Here we just have the risk of explosion and fire reported as a pictogram also. We have here the chemical risk and what are the preventive measures you can have, like having your PPE, and also to wash if you are in contact with the electrolyte and all chemicals. You have also mentioned the electrical hazards, and also that there is other dangers. For example, batteries are heavy, so this is the mechanical danger. And also that you may have to read the operating instruction. want using, during the maintenance, during the installation, when you retrieve it also, and when you want to throw it away because it's done. There is a lot of instruction to follow. And here we see other parts. It's how to handle the batteries, how to keep flames away, so avoiding the static electricity, and what kind of tools you are going to use, because it's still an electrical hazard and you have metal parts also present. So this is it. And also what to do if you want to recycle a battery, because if you want to throw it away, don't throw it away just like that. There is a lot of disposal for the used batteries, and also recommendations to follow in order to protect the battery, and after that to recycle. So this is what you can have, in fact, already sticked in the battery, and together with the battery, you have also the instruction.
We saw already a lot of hazards. Then we learned during the discussion what we can do, how to avoid this. Maybe we can do a summary of all the recommendations and good practices that we can apply for batteries.
Yes, indeed. For example, during the use, but also during the purchase, and when you receive it, first, I think it's obvious, but follow the manufacturer's instructions. Everything is written there, and the adapted PPE has to be worded, and everything is mentioned in the manufacturer's instruction. In the case of lead acid, there is a lot of standards developed, and the instruction of manufacturers take into account these standards, but the standards also provide you information about the ventilation, the temperature of the room, the gas detection you need to have, the safety distance you need to apply between batteries. Always charge the battery with caps in place, else you have really metallic part present, and you need to be protected against that. Before connecting or disconnecting a battery, always switch off the battery. Really, don't charge it, don't use it, and never forget that even if you disconnect the battery is always electrically alive. And as mentioned during the WEX just before, never mix all the new batteries, because you will achieve a safety event in advance, in fact, regarding the normal use. You need also to prevent any risk and any hazards you can have. For the electrical, you need to prevent, for example, the short circuit. So you need to remove all your metallic items you have, the jewelry, the wrist and the neck, on the wrist and neck. You need to use insulated tools and never place the tools or any other conductive object on the top of the battery while being used, while being charged, and if it's not protected. You always have to disconnect it, but never forget that it's always alive. You have to be sure that the ventilation is adequate to dissipate all hazardous gases you form when the battery is charged or discharged. And of course, in the charging area, don't smoke.
Thank you for all those recommendations. And what now if I have more questions and if I want more details about all those recommendations? So
there is different way to reach us. You can reach the Batteries Lab. So we are dedicated to various activities. We are divided into various expertise, let's say, like the battery heart, concerning the chemistry, what are the electrodes, what is, chemically speaking, your product, and what are you going to purchase. Also dedicated to system regarding all the electronics you can have, all the electrotechnical aspect you can have, and all the communication you can have. We test also the batteries within our lab under real conditions, applying real profiles from cell level, which is the unit elements, up to the finished product. So this is related to all the use we can have within the group. And also, if you have other questions, you can use the Global Care SharePoint on stationary batteries, where together with Global Care, NG Laborelec is producing documentations MOOCs. We have also the Take It Easy, which is describing the battery technologies. And like today also, this video is present on the Global Care SharePoint. And you can also reach the Batteries Lab through Yammer, through the page and contacts.
Thank you very much. Work safely with batteries then.
Yeah, thank you.